So the first part of the worksheet, 1, 2, 3, I'm going to do some of these. Of course, I'm not going to do all of them with you, but I'll do the ones that, like a one from each section to help you out, okay? So. Okay, exponential functions. We started it last year and review. So this one says to write an equation for each graph. Okay, so what does our general equation for a exponential look like? It's not y equals mx plus b, right?
Like it's a y-intercept that it's 2x, for example, or like 2 to the power of x.
So.
X squared.
Okay, so let's write this down. Yeah, y equals a times b to the x. That's why it's called an exponential, because it has an exponent in the equation, right? It has to have an exponent, and it's going to increase exponentially or it's going to decrease exponentially. So we could have an increase or we could have a decrease. The first one we're doing here has an increase, and A stands for what? The start value. Okay, so let's write that down on our paper somewhere. And the B stands for the multiplier, right? What we're multiplying by. If it's growing, your multiplier is going to be greater than 1. B is greater than 1 if it's growing. If it's decaying, then B is going to be less than 1, but greater than 0. So between 0 and 1, like 0.95 or 0.17 or any number between 0 and 1 can be, and that will make it decay. Okay, in order to make it go lower, you have to multiply by a number less than 1. Okay, so we want to look at our starting point, which means where does this curve cross through the y-axis? 0, 5, right? So let's label that point. It's always good to label your graphs. 0, 5. So that tells us one of our values already in our equation, right? Y equals 5 times some number to the x power. Okay, so now we have to find the b value. Like, this is obviously growing. How fast is it growing? Is it 1.72? Is it 2.5? What is the multiplier that we're multiplying by, right? In order to find that, we need to find another point on the graph. So what's another point that you see on here besides 0, 5? Okay, yeah, I see it might be 219, but let's go for the 1, 1. 1 what? I see a point right here. What point is that? 110. 2 could be 19 or it could be 20. I'm not sure if it's 2. It could be 19. I'm leaning towards 20, but we're not sure. It's not clear, right? Because it's too vertical to tell. But I know for sure this looks like 110. So I'm going to use the one I know for sure. Okay. When you have two values, let's make a table. And if you need extra paper and you need to do this on another sheet of paper, you can, because we're going to write a bunch of notes. It's hard to fit it on the side. So we know the 0 value is 0, 5. We know the first value is 10. And the second value, we're not sure of. We think it's either 19 or 20, but we know it's somewhere around there. Okay. These two values are called consecutive values. They're right next to each other. Okay. And to find your b value, you're always going to take the latter number and divide by the number that's before it. So should I write like y2 over y1, right? You take the second one and divide it by the first one. So I'd have 10 divided by 5, which is 10 divided by 5? 2. So that means the numbers are doing what? They're doubling. So what is that number up here? Is it 19 or 20? It's going to be 20, because the next one, in order to double this one, we'd have to have 20 here. What's the next one after that going to be that's not on our graph? Right? And then the next one after that, 80, right? And we could keep going because the numbers are doubling. We found that from just this relationship between these two and figuring, kind of using that one too. So our equation for this exponential graph is y equals 5 times 2 to the x power. Okay, and that's how easy it is to find the equation. Okay, so let's do one that's decreasing over here. I'm going to do number 3 right here because it's decreasing. And first thing, again, I'm doing number 3 here. Our equation is y equals, what is it, guys? A times b to the x. What do we want to look for first? What did I do with you first? The starting value. We want to start with the starting value, right? So let's look, where does this cross the axis? It looks like 0, 2, right? And be very careful. Yeah, a 0, 2, and label that. Okay, so I know this value is 2, so it's y equals 2 times some b value to the x power. Is this growing or is this decaying? It's decaying. Since it's decaying, it's getting lower. What do I know about my b value? It's less than 1, but greater than 0. It's in between 0 and 1. So again, let's make like a little chart, a little XY table here. And I know 0, 2. Here, I'm going to put 0, 2 right here. Why did I do that? Because maybe I want to pick a point over here. Like, what about -1? Where's the point at -1? -1, 4, right? Okay, good. So -1, 4. How about at -2? I go over to -2. The value is 8, right? Good. Thank you. It's at 8. -2, 8. And I could go to 1, go back over to 1. And what do I have at 1? Looks like 1, 1 to me. So 1, 1. So we have a bunch of numbers here, and you can kind of see what's happening to the numbers, right? Like if I go from 8, how do I get from 8 to 4, 4 to 2, 2 to 1? It's getting half, it's multiplied by a half, right? It's halving each time. But let's say you didn't see that because you didn't make a good table and or whatever, right? And you didn't see that. So what we could do is we could take any 2 consecutive values and put it, remember I said you do y2 over y1. So I take the second term 4 and I put it over the 8. I put the one that's in front over the one above it, okay? So 4 over 8, which is 1/2. So that tells me the multiplier is 1/2. We got a number between 0 and 1, so that's good. And half, half, half. I could do the next one. 2 would be what? What would be the next point right here? 1/2. Math teachers, we always prefer fractions. And then what would be the next one after a half? What's a half of a half? 0.25 or a fourth, right? And then what's a half of a 0.25? That's hard, right? But a half of a fourth is not hard. That's 1/8. Half of an eighth, 1/16. We could keep going. It's very easy. This is why we like fractions, because it's easy to just multiply by 2 to get half of it. Okay, so you can see these numbers are getting smaller and smaller and smaller and smaller. Will it ever go to 0? Will this ever be 0? No, because it's going to get closer. It's going to get 1 over 32. This number is going to get bigger and bigger and bigger on the bottom, but it's never going to go to 0. So it's never going to cross the bottom. So we have this like imaginary line. So if you have like, I don't know, a colored pencil or something, draw an imaginary line. If you don't, just use your pencil. That imaginary line is called an asymptote. Okay, and has a silent P in there. Asymptote. Okay. An asymptote is a line that a graph never crosses, but it's an imaginary line that's there. And on the back side, on the directions for number 9, it says with asymptote y equals 0. That is the line right there, y equals 0, is actually the equation of the x-axis. Did you know the x-axis has an equation? Because it's a line, so it has to have some kind of equation. And the equation for the x-axis is not x equals 0, but it's y equals 0. because every point on the x-axis has a y coordinate that is 0. That's why it's the opposite. Okay, so the equation for the x-axis is y equals 0. Guess what the equation for the y-axis is? X equals 0, because every point on the y-axis has an x coordinate of 0. So it's flip-flopped, okay? Okay, but usually all our asymptotes for today are going to be at y equals 0. Later on, we'll show you how to shift the asymptotes up and down and sideways and do fancy like stuff like that in Math 3, actually, next year. Yeah. Okay, so your job for number 2 and 4 later on is to come up with these equations, just like I showed you here. Okay, and I'm going to go on to the next section. So I need to clear these drawings and go on to the next part. Okay, so number 5. Oops, very sensitive, my keyboard. 5 here, it gives us the equation and we have to graph it. So we're going to do the reverse of what I just taught you, right? Okay, so for number 5, we have y equals 3 times 2 to the x. And notice that they didn't put y, they put f of x. Is that the same thing as y? Basically, yeah, it's a function of x. Okay, so what does the 3 tell us? It starts at 3, so let's write that as a coordinate. What coordinate is that? 0, 3. Okay, y-intercepts have an x coordinate of 0. So we know, hey, there's a point right here at 0, 3. That's 1 point, and let's label it. Put a big 3 there because these numbers are super tiny. I don't like super tiny numbers. Write a big 3 next to 0, next to your point. And I like to use x's for my points because dots are nice, but they're very hard to see. And if you put an x, I saw a teacher who did this like 12 years ago here, and I was like, oh, that's really good. So I copied her. Okay, so let's go ahead and make a table too. Use the lines. Use the lines on your graph paper. Oh, this is on graph paper. It's just a worksheet. We could put -2. We could put -1, 0, 1, 2. Probably the easiest to come up with numbers are these ones. These ones aren't that bad either. But 0, we already know 0, right? What's the value of y when x is 0? 3. Okay. And look at our multiplier, right? What is our multiplier? It's 2. So what should be happening each time to these numbers? You should multiply them by 2. So 3 times 2 is 6. 6 times 2 is 12. What if I go backwards? How do I do half of 3? Right? Don't we want to do half? Right? So this would be 3 halves, or you decimal people, 1.5, because if you didn't know, 1.5, 1.5 is half of 3. Okay, and then we want to take half of that. As a fraction, it's easy because I just multiply the denominator by 2 again, right? So half of 3 halves would be 3/4. Okay, so that's 0.75. Oh, did you know that 0.75 is half of 1.5? Yeah, right. You have $1.50, you want to take half of it, that's 75 cents. Okay, so now we have enough to graph. And when you graph these, you could use 2 points, but not really, because this isn't a line, guys. We need more than 2 points, okay? If it was a line, 2 points would be great, but this is a curve. We need like 5 points, okay? So don't just give me 2 points. So 0, 3, we do want you always want to label the y-intercept though. That's a super important point. You always want to label it like that. And then let's go to 1, 6. 1, 6 is right here. And then we're going to double that and go all the way up to 12. And if we have 24, I can make 24, right? 21, 22, 23. I could go to 24 just for kicks. It goes all the way up there. Half of 3 is 1.5. So when I go backwards here, 1.5 is right halfway between 1 and 2, right? And then I want to do 3/4 here, so close to the 1 line. And then I know it's going to be half of that, half of that, half of that, half of that. But is it ever going to cross the x-axis? No. So you need to show this when you do exponentials, that you know that it's getting closer and closer. So you need to make this part like get very close to the x-axis when you label, when you draw them. Okay, and then does this ever go straight up? No, because these numbers are going to keep doubling, right? So it's never going to be the same. It's never going to be 24 again. It's going to double. It's going to be 48, and the numbers are going to double, but it's going to be very steep, right? So we need to zoom out to see that go up. Okay, so this, if you want to do doubly good, we put an asymptote in there. We graph the asymptote like that. Okay. All right. So I chose to do number 6 as well. What's different? Look at the equation for number 6. What's different about number 6 than number 5? Bunch of fractions. So how's that going to affect our graph? It's definitely going to be going lower, right? Because the B value is what? Less than 1. Our B value is a half, right? Our B value is 1/2. What is our A value? It's also a half. This first number is our A value. So where does this graph start at? So here's 1, and it starts at a half. So it's way down here between 0 and 1. Starts at 0, 1/2, right? So 0, 1/2 is our A value. Okay. Wow, this is going to be hard because I know what's happening to the numbers. It's dividing it in half, and half, and half. So if I take, so let's make a little table. So I'm going to put a 0, 1/2. What's a half of a half? Remember, just double the denominator. If you want to take half of something, you just double denominator. So 1/4. What's half of a fourth for our next one? 1/8. What's half of an eighth for the next one? 1/16. We could keep doing this forever. Now let's go backwards. So if I want to go backwards, so I'm multiplying by a half here, multiplying by a half, multiplying by half. If I go backwards, I don't want to multiply by a half. I want to multiply by 2. If I go backwards, I want to times by 2, because I'm going backwards. So 1/2 times 2 is 1. 1 times 2 is 2. Let's keep going. 2 times 2 is 4. Let's keep going. 4 times 2 is 8. 8 times 2 is 16. We can fit all these points on the graph because it goes up to 20. So this is 0. This is -1. This is -2. This is -3. This is -4. This is -5. Okay, so let's start at -5/16. -5/16 is way up here. Hopefully I'm at the right spot. Okay. And then let's go down to -4/8. We do half of that, right? Half of that, here's the 8. -4/8 is right there. Then let's graph -3/4 is next. Here's -3/4. So half of that. So I just go over 1 and go down halfway. And then half of that is going to be 2. So I'm going to go down to 2. And then half of that is going to be 1. And then half is going to be half. Half of this is 1/4. Just going to get closer and closer and closer to 0, closer to the axis, but never quite hitting the axis. So let's draw a nice smooth curve through here. This is going to go up. Oops, it's really hard to draw on this tablet. Curve, 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 curve. Oh, okay, and show that you know. Don't chicken out. If you chicken out around here and just make your curve go like this, I mark them wrong. On my math 3s, when they do this and they chicken out and they don't show me that it's approaching the asymptote, I mark it wrong. You got to show me, you know, the end behavior is going to approach the x-axis. And if you don't put arrows at the end, another mark wrong because it goes on forever. Okay, so we did a growth one, we did a decay one. So given these pictures, what is this going to be, growth or decay? Okay, why is this one growth? Yeah, the multiplier is 4, right? So this is actually getting bigger, 4 times bigger each time. That's getting bigger fast. How about this one, growth or decay? This one is also growth. And how much bigger is it getting each time? By 6. So that one's going to grow even faster. That's going to grow very fast. That one's going to, you're probably only going to be able to fit like 3 or 4 points on here. Okay. So I need to erase this. Is everybody good with this before I erase it? Okay, let's go to the next screen. Next screen. Okay, so on the back side of your worksheet, flip it over. What if they don't give you a graph and there's just 2 points and they want you to find the equation? Can you find an equation given 2 points? Absolutely, because you know it's a curve, right? You could draw a line through 2 points or you can draw a curve through 2 points. Well, we're interested in the curves today. Okay, so let me change that to that. Okay, so I like to envision this by making a table X, Y, and putting the 2 points that we know. Okay, we know point number 1. What is the coordinate at 1? 1 and 12, right? We don't know 0. If we knew 0, that would be beautiful because that would be half of our equation done, right? So we're going to have to go backwards and figure out what the 0 term is because that's our A value. Right there is our A value. Okay. Do we know the second and the third term? No, we don't know second or third, but we know the fourth term is 768. Okay, this is where calculators, we're going to get calculators out. If you have the calculators, if you don't, you need a calculator because I'm going to show you how to use a button on here that if you don't have a calculator, you know how to use a button. Okay, if you really want one, you can borrow one of mine. You just have to put it back and sanitize it when you're done with the wipes over there. Yeah, go ahead and grab it. Go for it. What this? Oh no. Close that. It's really important you have a calculator for this class. Okay. Can you tell if this function is growing or decaying? It's growing. How do we know it's growing? Because the numbers are getting bigger, right? Because it went from 12 and jumped way up to 768. Okay, let's see how many times did we multiply them by the multiplier? Or I could take this 4 and I could subtract 1. And how many times did we multiply this? 4 minus 1 is 3. So we multiplied by the multiplier 3 times. Which if you do something 3 times, like what's x times, if this is my multiplier is x times x times x, what does that equal? X cubed. So in order to find b, we're going to have to undo this cube. We're going to have to take the cube, what's called the cube root. Okay, so if you have your calculators, I'll show you how to take the cube root on the calculator or my calculator. Your smartphone can do it too, but you'll have to figure that out later. Okay, so if I want to find the b value, I'm going to put the second one above the one above it. So the latter one always goes on top. Okay, this one always goes on top. This one always goes on bottom. Okay, so and since it's been multiplied 3 times, it's not just this is the b value. It's been multiplied 3 times. So we're going to have to undo that 3 and we're going to have to do the cube root of this. First, let's just do 768 divided by 12 in our calculator, see what we get, okay? 768 divided by 12 is, oh, nice, 64, that's it. So this divided by this is 64. But now we want to take the cube root of 64, okay? So to do that, you press 3, because you have to tell your calculator is not smart, it's very dumb. So you have to tell it what root you want to take. So we press 3. Press 3, then you press the second button. Then you press the power button, which is this caret button on the far left of your calculator. Okay, so 3, second, caret button, and then it will display the little third root on your display. Should look like this, and then type in 64, and this will tell you what number do you multiply 3 times to get 64. Okay, and it's 4. And if you just think about it, you can think about, oh, it's 4. Doesn't 4 times 4 times 4 sound like, if you don't have a cube root button, you could just try numbers. You could just try doing 4 times 4 times 4 and 3 times 3 times 3, see what you get. 5 times 5 times 5 and see what you get, right? So our multiplier is 4. It means we multiplied by 4 each time. Okay. So our equation, our y equals a times b to the x. Y equals, I don't know this, but I do know this is 4 to the x, right? Because our multiplier is 4. To find my a value, which is right here, the 0 value, I can just go backwards 1. So if I multiply by 4 to get the 12, to go backwards, I'm going to have to divide by 4. 12 divided by 4 is 3. So this number was 3. Doesn't that make sense? Because I multiply 3 times 4 and I get 12. If I want to find the next number, I'm going to, these two right here, what's 12 times 4? 48. 48 times 4, we'll use our calculator for that. 192. And then 192 times 4 better be 768. You can check it, and I'm sure it is. Okay, and then we could keep going if we want to. So we found our a value. Our a value is 3. So this is our equation. Okay, is y equals 3 times 4 to the x power. If I plug in 0 in here, I'll get 3. And I didn't show you how to do that directly. If you want to plug in a number, just plug it in to check it. Okay, like let's say I want to plug in. How do I get my pencil back? Here we go. Let's say I want to plug in 2 just to see. I want to see if my equation works. So I'm going to plug in 2 here. 3 times 2, I'm sorry, 4 to the second power. Okay, 3 times 4 to the second power. What do you do first? Do I multiply this 3 and 4 first and make it 12 to the second? No, that's bad. And people do this. I see this on standards quizzes. People say, oh, 3 times 4 to the second is 12 to the second. That's very, very wrong. Okay, you have to do the exponent part first. 4 squared is 16 times 3, which is 48. And so I checked my work and I plugged in a random number 2 and I got 48. It worked in my equation, and that is how you plug in numbers. You have to do the exponent part first and then multiply by the number last, because exponents come before multiplication. So if you make this 12 to the second, you're going to get 144, and that is not in our table. That is nowhere in here. So you do not ever multiply these first and then square it. Totally different answer. Okay. Okay. So the next one I was going to do with you is 13, because look at the numbers. Are they going up or down? This one's going down. Okay. So let's put which ones we have. We have, I should do it up here. We have, do we have the 0 term? Not that lucky, but we need to find the 0 term, right? Do we have the first term? First term is 81. Do we have the second term? No. Do we have the third term? Yes. Are these 3 terms away like the last one? To tell, just take these 2, the ones that we do have, and subtract them. How many away are they? They're only 2 away. So we're not going to take the cube root this time. I'd take the cube root if they gave me this one down here and there's 1, 2, 3, right? If they give me the fourth and the first term and they're 3 apart, then I would take the cube root. But since they're only 2 apart, I'm going to take the square root at the end, okay? So to find the b value, remember, we always put the second one above the first one. So it's 9 over 81. And then we're going to take the square root of that because we've multiplied by b twice. That's b squared, right? And we need to undo that square. So I divide by this one by this one. If you do this in a calculator, you're going to get a decimal. I don't want a decimal, ever. Fractions are, if you haven't figured it out, I hate decimals. Okay, decimals are not our friend in math. Fractions are far superior. They're exact. Decimals are approximations. You can reduce this without a calculator. This reduces down to what? 1/9. And you take the square root of it. If you put this in your calculator, you're going to get decimal. I hate decimals. I don't want a decimal answer because this you can do in your head. You just take the square root of 1 over the square root of 9. Square root of 1 is 1. Square root of 9 is 3. This isn't 1/3 times 1/3, 1/9. Okay, but if you put in a calculator, you're going to get an ugly decimal. 1/9 is 0.11111111. I don't want 0.111 forever. This is a lot prettier than 0.111 forever. Okay, so my multiplier is 1/3. That tells me what's happening every time we multiply, what's happening to the number each time we multiply. What are we dividing by? You're really dividing. You're not multiplying. You're dividing by 3 every time, right? You're multiplying by 1/3, or you're dividing by 3 every time. Okay. So let me erase this part right here. Got messy. So if I'm multiplying by 1/3, right? I'm multiplying by 1/3, multiplying by 1/3. I could do 81 times 1/3, or can I just do 81 divided by 3? Is that 27? No. It's, yeah, 27. 81 divided by 3 is 27. And then 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So we could keep going. Now, if I want to go backwards, because this is the one I really want to find, because that is in my y equals a times b to that. That's my a value. I need to find the 0 term always. Well, I just go backwards. How do I go backwards? Multiply by 3, because I need this number to be bigger, right? If I go backwards, the numbers are getting bigger. So 81 times 3. Yeah, 243, right? So this is 243. That is our a value. Good. We can now put it in here. Y equals 243 times what to the x power? 1/3. Okay. Yes. Okay. Let me erase. Oh no, I need to clear all my drawings and go to number 13 here. Okay, did we just do that one? Yeah, okay, great, awesome. So the last one is this section right here. Okay, so same thing for these problems right here. They gave you the table. So you guys can do this one? Yeah?
Yeah.
Okay, because you're just gonna find your y equals a times b to the x. They gave you, look, they're giving you the 0 value. They're giving you 2 numbers, so you just have to take one number divided by the other one and find your b value. I need to see that work though, okay? Don't just give me the answer out of thin air. Show me how you found the b value, okay, for both of these. This one skips a few, so we need to add some. I don't like this table how it is here. We need to do -1, 0, 1, 2, 108. This is better, right? So this is a little deceiving. So how many times do we multiply? Are we going to do square root or cube root here? You're going to do cube root because it's 3 times. I did 1, 2, 3. There's 1, 2, 3. The cube root of, I'm going to let you figure that out as I showed you twice already. Okay, 17 and 18, I'm just going to look at really quickly. Your new laptop costs $850, but it will lose 15% of its value each year. What will it be worth 6 years from now? So to find this, we need to write an equation of y equals a times b to the x. Okay. What's the starting value going to be? $850, right? So they told you the starting value, that's $850, that's easy. What's the multiplier going to be? Okay, Most people are going to say, oh, it's 15%. So to make this a decimal, you move it over 2 places, or you take 15%, you divide it by 100 to make a decimal, and you get 0.15. Either way, you move it over 2 places, or you divide by 100 and get 0.15. Most people are going to say that's 0.15 to the x. That's wrong. Okay, because you're only retaining 15%. You want to lose only 15%, and you want to it's going to retain more than 15%. So if it's going down, you can't do 15. You have to do 100 minus 15. Okay, you have to subtract this percent from 100 if it's decreasing. You only have to do that when it's decreasing. Okay, and this is decreasing, something that's devaluating each year. What's 100 minus 18? 85%. So it's going to retain, does that make sense? If it's losing 15% of its value, it's going to retain 85% of its value. And so we want to find 85% of the value. We don't want to find 15% of the value. So what is 85% as a decimal? Move it 2 places, it's 0.85, right? So this multiplier needs to be 0.85 to the x, not 15, okay? And still starting with 850. So if I want to know how much is it going to be 6 years from now, what do I do with this equation?
Plug in 6.
Plug in 6. You got my calculators? Go ahead and plug in 6 and do 850 times 0.85 to the 6th power. You have to use that little, this is the exponent button. The little caret button is the exponent button on the far left. Okay. If you have an old calculator like that, it doesn't have a caret button. It has a button something like this, y to the x. Don't use the e to the x button. That's something completely different. It should say y to the x or x to the y. Okay. TIs have exponent buttons, but other calculators have, like Casio's have buttons like this. Sharp has buttons like this. It depends what model you have. Yeah. I can't hear you. No, it's just somewhere on there. Oh, like what place? Like the tenths or the hundredths, like the 2 decimal places. Okay. So round to 2 decimal places, since this is a dollar value. Okay, so try number 18 here. The electrical signal is 500 millivolts or something now, and has been increasing 25%, increasing 25% each year or every second. What is its strength 4 seconds ago? Okay, if it's increasing, then the B value needs to be
1.25.
greater than 1, right? So if I were to make 25% as a percent, as a decimal, what would that be? 0.25. Is that bigger than 1? No. If you multiply by 0.25, you're going to get a number smaller than what you started with. And this says it's growing. We want it to grow. So how do I make it grow 25%? You take 100 and you add it to the 25%. So 100 plus 25 is 125%. What decimal is this? If I change this to a decimal, I go 1, 2. What decimal is that? 1.25. So if you want something to grow 25%, you need to multiply by 1.25. Okay. So our multiplier is 1.25. Our y equals a times b to the x. That's my b value, right? To the x power. What is the starting value? It's the only other value in the word problem. 500. We want to know how much it was 4 seconds before this. So what do we plug in for x 4 seconds before this? -4, right? -4. So, yeah, you can plug in negatives. Put in the calculator, make the calculator. This is why you have a calculator, because I'm pretty sure nobody can do 1.25 to the -4 power in their head. You make sure you use the negative button, not a subtraction button. If you try to use the subtract button for negatives, it will not work. Did you guys get? Okay, you should have got, yeah, 204.8 millivolts. So let's see, that number is smaller. Should it be smaller 4 seconds before? Yes, it should be smaller 4 seconds before because this graph was going up. Sometimes I like to draw a little, just a little, you know, visual to help me see what's going on. That's a good idea. Okay. This is when you want to test and make sure you put it in the calculator and you get the correct answer. Because if you're not doing this with me and you go to do it on a data test, you have no idea how to use the calculator. You have no idea if you're putting it in right. That's why it's important you follow along and do it with me. Okay. I need to clear this out. Okay. The other worksheet, I haven't given it to you yet, so I need to give it to you. It looks like this. All right, so on this worksheet it says write an equation showing area as a product and a sum. Get my pen back. If this is x squared, what are my length and my width for this? If this is a square, and this would have to be x times x, right? So you want to fill that in. What is this little one? Remember the unit tile? What is the little one going to be? 1. So that's 1. So this is an x plus 1. And then how many little ones do we have here? Plus 3. So really this is x plus 3 times x plus 1. And if we wanted to multiply that, well, how many, this is what kind of tile is this? X squared, right? What kind of tile is this? That's an x, that's an x, that's an x, that's an x. How many x tiles do we have? 4x, so plus 4x. How many unit tiles do we have? 3, so 1, 2, 3. So I don't even need to do the generic rectangles. X plus 3 times x plus 1 is x squared plus 4x plus 3. Isn't that beautiful? The tiles are pretty fun, actually, once you get to use them. So what is the dimensions here for this x squared? X times x. To get x squared, you'd have to multiply an x times x. What is this here? Well, this is x. See, this is an x and that's an x. So this is another x right here. This x is already over here. See that? This is x times 1. Okay, so the x is over here. So this is an x tile. All these are x tiles. But we don't put an x here because their x is already over here, right? So what is this length and this little length and that little length right there? That's 1 or 2 since there's 2 of them, right? So it's 2. So x plus 2 times, we add these together. What's x plus 1? If I were to add these together, 2x plus 1 equals, now we count everything that we have. This is an x squared, right? How many x squared tiles do we have? 2 x squared tiles, all right? If I were to multiply x times 2x, wouldn't I get 2x squared? Yeah. Right here? Because there's 1, 2. So I added these together. A 1 and a 1 make 2. Okay. And then how many x tiles? Next we count how many x tiles there are. There's 5 x tiles. And how many little baby unit tiles do we have? Plus 2. 2 little babies. There we go. So product sum. Remember we did this the other day. We write it as a product. This is the product part. This is the sum. Okay. So what are my dimensions for this x squared right here? X times x. We already have an x over here. X times what's over here? X. And these little ones, how many little ones are there? So that's 3. We're going to add this together to get our first dimension. X plus 3 is 2x plus 3 times, now we got to do how many little, I already have an x here for this dimension, right? So how many little baby ones? 2. So this side is x plus 2. This is an x squared just like the one next to it, right? So how many x squareds do we have? 2. You're really just counting the tiles. That's why the tiles are fun. You just have to count how many there are. And then these are all X tiles. 1, 2, 3, 4, 5, 6, 7 X tiles. So plus 7X. And then count how many little baby unit tiles we have. 6, right? So if I were to multiply this out, if I were to multiply that times that, I get a 2x squared. If I were to multiply that times that, that times that, that times that, I get plus 7x plus 6. And that's the visualization of that. So the tiles are fun. And so hopefully you've seen that. If not, that's your first time. There you go. Yay. Here, instead of doing all the tiles are fun, but would you like to draw all those tiles? No, right? So that's why we have this. So go ahead and write your, so we do them as generic rectangles, okay? What's our first parentheses? X plus 3 times. They do it a little backwards. This is a little backwards. I like to put the x's here and the minus 5 here. Does it matter if I switch it around? No, so it's just going to be x minus 5, but don't put like minus 5 plus x. That's weird. I mean, you could, but it's just weird. Once in a while, you'll see something like that, but it's better to write it like this. Then we just add all of them together. Which one do I start with? The x squared. Combine the two that diagonally that are the same, like terms. Negative 5x plus 3x is negative 2x. And then lastly, it means we'd have negative 15 little baby tiles. Okay, so product sum. This is how you write something as a product and a sum. You're going to be asked to do that on a test. Write it as a product and a sum. So you have to remember, don't just write the answer. Don't just write the sum part. You have to write the product part too. Okay. So you get the hang of it, right? For these other ones right here. I'm not going to do all of them with you. I did 4 of them right there. The next part of your, so we want you to do the same here. Should you make rectangles? Yes, you need to make rectangles, okay? And you need to make rectangles for all of these. Okay, and then here's the product. So you could write the sum at the end. It says write it as a product sum, or you could rewrite it and write this is a product and then the sum. Okay, so yeah, all of these need to be rectangles, every single one, to show your work. This one is only going to be a 1 by 2, right? This one's going to be a 1 by 2 also. Okay. So yeah, after you do the rectangles, make sure you write the sum answer next to it, okay? So the rectangle is not an answer, it's the work that I need to see, but it's never an answer. You have to translate the rectangle work into here, just like the ones that we did above it, right? Just like the one we just did. So you're gonna do those there. So our what, 3x plus 2, right? That it's going to go down there, and then 2x plus 7. Or if you did it opposite, that's fine. If you reverse these, it's fine. You're going to get the same answer. Okay. All right, and that's it, guys.
Now we're done.
After we go out, hold on one second.